Welcome to the next installment in my video lecture series for managerial economics, and we are on chapter 14 of Q&As, and in this one we're going to take a look at Q&A 14.4 from the textbook. And I basically just redrew the decision tree for this particular problem, but let me actually read out the problem for you. We have been assuming that nature dictates the probability of various possible events. However, sometimes we can alter the probabilities at some expense. Gautam, who is risk neutral, is considering whether to invest in a new store, as figure 14.5 shows, and that's what we have on our screen right now. After investing, he can increase the probability that demand will be high at the new store by advertising at a cost of $50,000. If he makes the investment but does not advertise, he has a 40% probability of making $100,000 and 60% probability of losing $100,000 should he invest in the new store. So let's take a look at the decision tree here, and let's just go over a few basic things about the decision tree. You can see here we have a couple of blue rectangles. These are referred to as decision nodes because decisions have to be made. These light green round items are called probability nodes because there are probabilities associated with that particular situation. So the initial decision that Gautam has to make is, do I invest or do I not invest? And then once he decides whether or not to invest, he has to decide whether or not to advertise or not advertise, and we have the price of advertising. If he does advertise, there's an 80% chance that the demand will be high for his product and that he will see a profit of $100,000. But there is also a 20% chance that the demand will be low for his product and he will lose $100,000. If he does not advertise, there's a 40% chance of high demand with profits of $100,000 and a 60% chance of low demand with losses of $100,000. So the way to work through this is to go through right to left and figure out what the expected value of these two different situations when he advertises versus do not advertise. So if we take a look at this, we want to calculate the expected value or the expected profits that he will have if he does advertise. So if he does advertise, the expected value is going to be 0.8 multiplied by 100,000 plus 0.2 multiplied by negative 100,000. So if we work that out, the expected value or the expected profits of advertising are going to be 80,000 minus 20,000, and the expected value of advertising is going to be a profit of $60,000. Now we do the same thing for when he does not advertise, so we have EV and NAD for not advertising, and we have 0.4 times 100,000 to represent this state of nature, and 0.6 multiplied by negative 100,000 for this state of nature. We multiply those through and we get the expected value or profits for this venture when he does not advertise to be 40,000 minus 60,000, and the expected value when he does not advertise is negative 20,000. So we figured out the difference between the expected values when he advertises and does not advertise. But remember, when he advertises, this entails an expense of $50,000. So we have to subtract the advertising expense off of the expected value in order to move forward with this. And we see that that gives us an expected value of $10,000. So if we look at the different states of nature, if he doesn't invest, doesn't even bother going into business, the expected outcome is zero, no profits whatsoever. If he does invest but does not advertise, he's expecting to lose $20,000. And if he invests and does advertise, the expected value is $60,000 minus the expense of advertising, which is $50,000. So the expected value of investing and advertising is going to be $10,000. So given this situation, he would be better off to invest and advertise because he would have an expected value of $10,000, where if he does not invest, he will have an expected value of 0, and he is also better off versus investing in non-advertising because his expected value would be a loss of $20,000.